In this video, I'm going to show you that there is another way to graph, and that would be because there's another form. There's a form called the vertex form, and this is different from the standard form. So far, we've only been graphing in standard form, which is that y equals ax squared plus bx plus c. Well, I had you factor for a reason, and I had you complete the square for a reason. Whenever you completed the square in the other assignments, it was actually turning your quadratic into vertex form. And vertex form is pretty cool because in vertex form, this number, whatever this number is, this is just a number, and that number is one of your factors from whenever you completed the square. So it's not just the number, but it's also a factor. And this is the x of the vertex. Well, it's the negative x of the vertex. You remember how whenever we would solve those factors, the answer would always be the opposite version of what was inside the parentheses? Well, that's because in the formula for vertex form, we have a negative sign in front of h. And then k is the number for the y of the vertex. And k is just the number. It's anything that's outside of the parentheses that's being squared. So let's just go ahead and go to number 1. In number 1, we have a plus 1 inside the parentheses. So that means whenever you're solving this factor, you're going to have to subtract that 1 at some point. And because we're going to have to subtract that 1, that means that the x for the vertex is going to be the opposite version of that number. So the vertex is going to have a negative 1, and it's going to have this number exactly how it is, 3. So the vertex for this quadratic is at negative 1, 3, negative 1, 3, and then we can look at this number in front. The number in front is going to tell you if the graph is going to open up or down. Since this is a negative, the graph is going to open down. And it's a negative 1/3. So that means not only is it going to open downwards, but it means that compared to the parent function, we're going to have to multiply the parent by negative 1/3. So let's take the parent numbers, x squared, and 0, 1, 2, 3, 4. 0, we're going to multiply that by negative 1/3. Well, let's just put the real answers first. The normal answers for the parent function would be like this, where we're just squaring the number. The new answers for the parent function, because we're going to have 1/3 x squared, negative 1/3, we're going to multiply by that factor that's outside the parentheses. So we're just going to take these old y's and multiply them by 1/3. That one's not going to change. This one will change to negative 1/3. This one will be negative 4/3. This will be negative 9/3, negative 16/3, and then we can simplify negative 3, and then these other ones are ugly, but this one's kind of not, so negative 5.3. So what we're going to do is we're going to pretend this is the origin. We're going to pretend that the vertex is the origin because every parabola, every quadratic is symmetric around the vertex. So we can treat the vertex as the origin of our parabola. So this is going to be our 0, 0. Then we're going to go over 1, down 1/3, over 1 more, down to 4/3, over 1 more, over 1 more, down 3. So I'm 3 lower than this origin here, the vertex. And then for the last one, 4 over, and then down 5 1/3. So here's 3, 4, 5 1/3. And then we can use the axis of symmetry to reflect those points evenly. And there we have a graph. Vertex, -1, 3. Axis of symmetry, x equals -1. Solutions are the roots. We have one at -5. Nope, -4. The other one is at 2. And those are the x solutions. The domain, all real numbers. The range, -infinity, less than y, less than 3. Let's do another. This number is the opposite of what's going to be the x for the vertex. So if that's a 4, the vertex is going to have -4. We have no number outside, so that number that's outside there is a 0. So -4, 0 is our vertex. From here, we look at what's outside. Is there anything outside there? No. So that's the number 1, because it would multiply. This letter A multiplies, and the letter K adds. So since we just have the number 1, we can take the same numbers that are from the parent function, 0, 0, 1, 1, 2, 4, 3, 9. Those are the parent functions for x squared. And we can just pretend that this is the origin. This is the new origin. New origin. 2 to the right of it, and then up 4 is going to be our second point. And then the next one's not going to fit, so I'm going to go in the other direction. Using the axis of symmetry, I'm going to mirror these points over. And there we go, a second graph. Label the vertex, -4, 0. X equals -4 is the axis of symmetry. There is only one solution, and it's at x equals -4. Domain is all real numbers. Range is 0 less than equal to y, less than infinity. I need to put an equal to sign on that first one over there. And then we'll do one more example. Let's say, we always start with the vertex. So this is a +1. So that means the vertex is going to have a -1. This is a +3. And that one gets copied exactly how it started. So -1, 3. -1, 3 is the new origin. Then I'm going to take the original numbers and multiply them by -4. So instead of writing the original numbers again, I'm just going to look at these, and I'm going to multiply the y's by -4. So 0, 0 is good. Then I'm going to multiply the second one times -4 times -4 times -4. Well, I could put times -4 on the 0 also, so I'll just go ahead and do that. And we can see that the next y is going to be -4. So from here, we go 1 to the right and then down 4. Then the second y is 2 to the right of the origin, two to the right, and then down 16. So that's way off somewhere down there. So that means I can only really fit 1 point. So I'll reflect that one over, and then I'll put a pretend dot down here, and then make my parabola. Vertex is at -1, 3. Axis of symmetry, x equals -1. Solutions, well, those are kind of hard to see, so we'll just estimate. X equals -2/3, 1, -1 and 2/3, and the other one I'll put as 1/3. Maybe it is, maybe it isn't. It's close. It's estimating. If we wanted to find the exact solutions using vertex form, then we would need to do substitution. We would put in 0. 0 equals the equation, -4x plus 1 squared plus 3. Move the 3, divide by the -4, square root, plus or minus, subtract the 1, plus or minus square root of 3/4 minus 1 equals x. And so that answer would be x equals -1 minus square root 3/2, -1 plus square root 3/2. I don't know what those exact answers are. Square root of 3 is like 1.7 or something, so 1.7 divided by 2. It's pretty close to what I put up here for the solutions. So I'll just change this to a about. But you already know how to find those solutions. You've done it on several worksheets already. Domain, all real numbers. Range. This one has a maximum, so -infinity is the minimum, is less than y is less than 3, less than or equal to 3.